Hello viewers, Alan here, welcome to my workshop, and perhaps I'll start by wishing you all a happy new year and hope it's a good one for you. But resuming with my Webster engine project, more progress, mostly to do with the lubrication this time. Let's just dive in and get on with it. So this part called for 5/16 or 8mm hex brass as the starting point. Well, I didn't have any of that, so started off by I had this old bit of I don't know what it was, a lump of brass with the thread on it. Anyway, I turned it down to 3/8 of an inch to give myself a bit of a standard thing to work with. So we'll part that off and then use that as our stock. So I think that'll do us nicely. And I've turned this diameter down to 8mm and put a 0.7mm pitch thread on there. It's a non-standard thing, M8 with 0.7, but I'm making the other half, so it doesn't matter. That's just about as fine a thread as I was comfortable to do, 0.7 pitch. So now I need to have a band around here which has a hexagon shape cut on it, because on the other side there's the threaded piece that goes into the actual stub that supports the little end bearing. This is, I should have said, this is the end for the grease cup. So I'm going to come across here now and cut the hexagon at about 2.5mm wide. And hopefully that's cut it flat without cutting my threads. It looks like I have, so that's good. Right, we'll rotate him round. Cut another one. This is the last one. So hopefully the ring spanner fits now. Oh, look at that. Like a thumb in a, well, you supply the whatever. Very happy with that. So that's one end of this thing pretty much done. I'm going to turn it around now and reduce this diameter down and put an M4 thread on it. So I've made the bottom part of this grease thing, and it wasn't too bad, although you can see it's pretty small. So now I've got to try to make the top piece, which will be the cap that screws onto this. So I've got to thread this with a 0.7mm pitch, and I didn't have any internal threading tools that would do that, so I've ground up a special cutter, and with my eyesight that's a bit of an ask. We can only try, but I'm starting to think I was really quite optimistic, thinking I would be able to do this. Anyway, we'll give it a crack. Now, being a pitch of 0.7, I can't disengage the half nuts once I start, and I've got to go in 6.9. There's a few things waiting to trip me up here. I've got the lathe set to run as slow as I can go, give myself the maximum chance of being able to control the stop when it hits. This is a blind hole that I'm tapping just for an additional complication. Now, the minor diameter that I'm starting from is 7.1, and the fully involved diameter should be 8. So anyway, I'm going to start obviously from 7.1. And I think for my first cut we might go for 7.5. Actually, I'll just back up a little bit first, just so I can see for myself the speed this thing's going to move at. Hopefully speed of a crippled snail. Yeah, alright, well I think we can probably go a little bit faster than that. I think that's actually starting, which is a minor miracle. There we go with 8.2. It's definitely easier. I'm not sure though whether part of the problem will be the profile of my thread. I might do better just flattening the peaks off this a little bit before I do anything else. I'm pretty sure the cause of the problem is the profile of the cutter that I ground. I can hardly see that. Anyway, and it's possible that it's not quite the correct angle either, but either way it's made a thread that isn't quite right, but apparently will work, so I guess I'm happy with that. Actually, I think I'll break that off. So there we have it. Little grease cup. We're going to see if it fits on the engine now. Alright, well that bit installed alright, and this bit, as you've seen already, will go in there. Okay, so I decided I wasn't happy with the fit here. It went a bit loose at the start, and it didn't want to go all the way in. So I went back to first principles and re-examined all of the aspects of the job, and I found a number of little things which all added up together. I hadn't bored the hole in this cap to full depth, so the threads didn't go quite deep enough, so it was always going to be an issue with when we got to the end of the thing there. But probably the major issue was the way I'd ground this tool wasn't very good. I've got a couple of pictures here to show you, like a before picture, and you can see it just doesn't fit the thread profile very well at all, and an after picture where you can see it's much better. And it is also the way I ground it, it's not at 90 degrees to the shank, so I needed to actually rotate the tool slightly in the tool post to get the V correctly aligned. But with that done, I've got a much better result. As you can see, my fumbling fingers will let me get started. Right, you can see that there's really quite a good result here. It gets quite tight at the end, and I don't think that's a bad thing, but it will quite easily go all the way in. So I'm very happy with that, so I'm going to part this guy off, and the other one can join the pile of bits that won't make it to the final result. Now, when I was making and fitting this grease fitting, I noticed that I hadn't drilled the hole to allow for the grease to actually come through and out. So I thought, well, better sort that out. when I checked the drawing calls for the hole to be in the centre of the length of the pin, but when I checked my dimensions carefully, I wasn't confident that that would actually clear the end of the grease input. So I've moving the hole over slightly, moving it over 0.1 off centre, just to make sure that the grease has got away into the bearing. That didn't feel quite right for some reason. We are through. I think it just felt funny as it was the drill was coming through the threads on the inside of the hole. Anyway, just got to deburr that a little bit, and then that's that job done. Okay, well, I'm happy with that. You can see in the picture that the end of the lubricator shank fetched up right smack in the middle of the hole in the crank pin. Okay, so I've made the greaser for the crank pin. Now I'm going to make 2 oilers for the crankshaft. These are pretty simple things. They're just several diameters and a thread on the end, and a hollow on the other side. Have to calibrate the DRO. So the DRO thinks that's 9.0. It's 9.285, so we've just got to update it. And we've got 9.01. That's good enough. So let's cut some of these diameters. So the first one is 8.73 for 11.9. Now we've got 6.35 4mm for an M4 thread, and we want 4.76 of this. That's the guts of it. Now I've got to put a chamfer there and turn the M4 thread on there. I think we'll call that it for the chamfer. Now we've just got to put that thread on there, the end. Oh, got to put a chamfer on there as well, I guess. Now because this is a very short thread, I'm not going to try and power tap it. Just get started and then turn the chuck by hand. So it looks like all the thread cutting might have been out of focus, so I'm sorry about that. Anyway, what's left to do is turn it round in the chuck and drill from the other side, but there has to be a hole that goes right the way through, so I could drill the small hole from this side and then meet up with it with the big one from the other side. Make sure the little hole comes out in the middle, so I might do that. Well, I think we'll have a go with the 1mm drill. Now we go for the top speed here, I think. I don't use 2000 RPM that often, but that's what we're going to use here for a 1mm drill. Alright, well, we managed to do that without breaking the drill. Quite pleased with that. So now we've got to turn this round in the chuck and bore it from the other side. I think that'll be right. We'll chop it off at that. Now, don't think we want to be doing this at 2000 RPM. So that's one of them. I think that turned out looking alright. Just got it put back in so I can deburr around those corners. Yeah, that feels good. Okay, so one done, one more to make. So I'm moving on now to make the cylinder oiler, and I'm working from a 19mm OD brass stock. I've got to turn down the OD for two features. The first is 9.5mm for about 10mm, and that will have an 8mm across the flats hex milled into it. And now I go down to a 5mm stub for an M5 thread to match the tapped hole in the cylinder. And because this was a very easy thread to cut, I just did it using the handheld die holder, and I was able to feel it up close to the shoulder. Using a die, you can't tap all the way up to a face like that. There's a piece, an unthreaded piece. And also I can't allow this thing to be too long because it will fail on the piston. So I'll have to do a fine adjustment on the length of this thread, and I'll achieve that by putting a spacer in here, or a shim in here. That'll take up the unthreaded piece, but also allow me to get the maximum depth of engagement of this thread in the cylinder. Alright, so I need a 1/16 diameter drilling through there. I'll do it from this side to make sure it starts in the middle of the space where it will protrude, and I've got to go into the space that will be made by the drilling from the other side. So if I go in 12, we should be fine. So I'll clean this face up and bring the piece to length, and then to create the chamber I'll drill in first and then use a boring tool to open it out to size. So I have to bore this side out to 15.9 or 5/8 for a depth of 14.2 or 9/16 I guess. Anyway, this pass will be 14mm, so we're getting close to size. Right, so this will be the final pass for 15.9. Now the actual diameter here is not that important, nothing mates up to it apart from the oil that's going to go into it. Always good to try for the numbers on the drawing. So 15.902, I'll take that. Okay, so there's a small hole, 1/16, which goes all the way through and out the other side, but then there's a smaller hole which is to be tapped for M3, and that doesn't go all the way through. So I'd like to just check to see how deep that piece is so I know how far the tap needs to go in. So I'm going to use this little trick here. This is the 2.5mm drill that I used for doing that hole. If we put that in there and push it in until it hits the bottom of the hole, now I can directly measure how much length of thread I'm going to have. I mean, it would be nice to think that I'll be able to feel when the tap bottoms out in the smaller hole, but I don't want to take a chance on breaking the tap. So this is just a rigid point. If I just there, and I can get a direct reading here. I'm on 26mm, so I don't want to go in past 34mm. We've got 15. Now we've got 8, so it's gone in 7. Right, I think that's good enough. So I'm making the exhaust pipe according to the plans. I've chosen to make it out of aluminium to keep the weight hanging off the side of the valve block down, and it's quite thin walled, so I'm a bit nervous about doing this machining, but we'll take it very gingerly and see how we go. Now the microphone died at this point, but nonetheless what we can see, I decided to use a relatively small diameter cutter and move around the edge of the tube, at the edge of the cut, because I didn't want to risk using a large cutter which might have generated enough force to damage the lip that I was trying to cut. I might have been panicking unnecessarily about that, but anyway, this small diameter cutter worked out really well, and got a good result. So you can see I finished the exhaust pipe and installed it. I was quite pleased to notice when I finished making it that it has almost no weight, because it's a short piece of very thin walled aluminium tube basically, so my concerns about it moving around were completely unfounded. Installation was a case of pressing it into a hole in the valve block, and in my case I had an interference fit of 1.5 thou, something like that, so it was a very firm fit, not a press fit, but I had to push quite hard. I had a punch I used as a driver and just pushed it in with that from inside, so I didn't damage the thing. Anyway, so that's that done, and if we turn him around a bit, you can see now that the engine is supporting all of its brass jewellery, the cups for the crankshaft oiling, the grease thingo here that looked after the crank pin, and the cylinder oiler which you saw me make with its regulating screw. As it happened, I had exactly the right spring for that according to the drawing. It's the right gauge and the right number of turns, so I had a lucky win there. So I think that's made all of the moving parts now. I do still have to pin the flywheel to the crankshaft, and you do that by drilling holes through the flywheel hub with the valve gearing in the correct orientation. I think that's non-trivial, but I'm not too worried about doing it. It's just a matter of making up a jig or pointers or something to make sure everything's in the right place. Okay, so now perhaps it's time to address the elephant in the room of the fuel system and the carburetor. There's three options. You can use the design that the engine designer provided and make a carburetor. He doesn't recommend that because it's pretty rudimentary. There's a thing called a vapour tank or a vapour carburetor, which literally the engine runs on the fumes coming off the surface of some fuel in a tank. Don't fully understand how all that lot works yet. The third option is, of course, to buy a carburetor, and that'd cost me about $100 including freight to do that. Now, given that the genesis of this project was using up scrap pieces on hand, I'm very reluctant to go down that path. I'm only into this thing for about $20 really at the moment for the contact points and the condenser. I don't count the cutters I bought for the gearing because they're in the toolbox for other projects. Yeah, so I have to decide which way to go. And as for the fuel tank, I do have a piece of scrap brass water pipe. That's the end that I chopped off it. It cleaned up nicely, so I've now got quite a thick walled cylinder. And I bought a couple of Welsh plugs to use as end plates. But until I've decided on what I'm doing with the carburetor, I can't finish the fuel tank because the height of it and where the connections go to it depend on the carburetor choice. Okay, well that's brought you up to speed with where I'm at with the project. This has taken a lot of time over the last couple of 3 months, as viewers of all of the videos might realise. I have to sort this carburetor out, as I've said, but really I'm not in a hurry to do that. There's a whole lot of other stuff that's on my horizon for the time being, and I might just be putting this a bit to one side for the moment and getting on with some other stuff. not least of which, for example, is doing some service or maintenance work on my new lathe, which I've had for a year now, and at the very least it needs is an oil change. Anyway, I will come back to it, but I don't know exactly when that's going to be. But thanks for joining me, and I hope you've enjoyed the journey so far, and hopefully we'll get to a running engine at some point. Cheers.